Hi everyone, I hope you are doing well. I am Prabu K, Assistant Professor, School of Computer Science and Engineering, Galgotia University, Delhi NCR, India. I would like to present my research article titled A Framework for Dynamic Monitoring of Distributed System featuring Adaptive Security. Paper ID 39902. This presentation will cover abstract, introduction, literature survey, proposed method, methodology, result and discussion, conclusion and future scope, references, and the co-author details. The abstract of the research article is distributed systems enables seamless communication across governmental, industrial, social and non-governmental institutions. The increasing complexity of information raises concern about the heterogeneity and dynamicity of distribution systems. Information and services are often disseminated across multiple sites, particularly in Web 2.0 environment. A high level of quality service is essential for accessing and disseminating information over remote sites despite insecure communication systems. Distributed systems are expected to implement security mechanisms, deliver services within acceptable response time, dynamically adapt to environmental requirements, and secure key informations. This research proposes a framework to evaluate and determine a threshold for data collection in distributed system for adaptive purposes. A dynamic security matrix is introduced to assess the security disturbance caused by the monitoring system during the adaptation. The role of monitoring system in protecting adaptive distributed system is detailed in this research article. An adaptive monitoring system is proposed to modify its functionality according to environmental changes. Introduction to our research article. Adaptive distributed system adjust behavior and set up dynamically based on failures, user needs and communication patterns. ADS continuously monitor and adapt to new conditions unlike static systems. ADS collects large amount of data from subsystem enhancing flexibility but increasing vulnerability to intrusions. Monitoring components gather extensive environmental data which introduce security risk. Limiting data collection reduces system flexibility but enhances security. Security measures based on user needs that help to maintain a balance between flexibility and protection. Common threats include changing, inspecting, interrupting, and fabricating informations. Availability, privacy, and integrity are essential to maintain system security. Security metrics assess risk based on the size, detail, and importance of the collected information. These metrics can help to prioritize actions to reduce the risk. The system changes its behavior based on the criticality of the data and the environmental changes. Important alerts are triggered the encryption to securely transmit the data. Metrics dynamically adjust based on the value of the information asset and environmental factors. The system ensures appropriate steps are taken according to updated security metrics and the conditions. The proposed system enhances security and adaptability by continuously adjusting to the changing security metrics and the environmental needs. The key problems in the adaptive distributed systems are monitoring systems collect extensive environmental data to enable system adaptation. This data collection occurs outside the target system, increasing vulnerability to the intruders. Intruders can access sensitive information gathered by the monitoring system. As data collection technique advance, the risk of exposure also grows. Restricting data collection to a certain threshold can help to minimize the intruder access. However, excessive restrictions may impair the system adaptability and security maintenance. A comprehensive understanding of the environment and the potential intruder exploitation is crucial to prevent the security breaches. And the following core issues are addressed in our research. The level of knowledge required for monitoring the system, to develop an adaptive distributed monitoring system, to identify the mechanism used by the intruder to exploit this knowledge, to define an adaptive security metrics to determine the security level, and to develop and incorporate a framework for an adaptive distributed monitoring system under the security metrics. Many literatures are studied to understand the problem and to identify the gap. So, few are listed here. In the first literature review, the focus was on applications of self-supervised learning in IoT security, and the methodology employed is self-supervised learning, clustering similar examples, and the findings are improved security in IoT system using both IoT and LATAM, DDIOS DDoS and IoT datasets, and the challenges encountered are maintaining quality and diversity of training data in dynamic IoT networks. In the second literature, the focus was hybrid deep learning for IoT network attack detection. The methodology employed are CNN for feature extraction and LSTM for capturing temporal dependencies, and the key findings are capable of detecting range of attack types adaptable to various IoT environment, and the challenges encountered are high computational demand limiting real-time applications in resource constrained environment. And in the third literature review, the focus was lightweight machine learning based ideas for IoT in smart homes. The methodology employed are two-layered architecture with XGBoost, edge and cloud computing. The key findings are achieves high accuracy and efficiency in real-time intrusion detection. The challenges encountered are complexity and reliance on cloud infrastructure, dataset generation are the challenges. And in the next literature review, hybrid deep learning based IoT for IOHT environment is the focus. The methodology employed are combination of ANN, BLSTM and GRU tested with ECU IOHT dataset. Key findings are high accuracy, high detection and reduced false rates. The challenges faced are the model complexity and need for continuous updates. And the next literature review, the focus was generalization challenges in machine learning based ideas. The methodology employed are analysis of high order representation learning in network anomaly detection. The findings are critic assumptions in anomaly detection, calls for better training, data and evaluation stages, and the challenges encountered are struggle to generalize effectively to a new data set. So based on their findings and based on these challenges, we have formulated the gap and we have formulated the problem. Finally, we have set the objective. Based on the objective, we have carried out our experiments. So here we are proposing a method. So this method, here the information is extracted during runtime to adapt or to reconfigure the distributed system. This process is divided into change detection, agreement and action driven by event based paradigm. The monitoring system collects and reports changes to a central system which reconfigures the distributed system accordingly. Two hybrid monitoring triggers to initiate data recording, which are memory mapped using predefined addresses, and the second one coprocessor based using processor instructions. The monitoring architecture components are bus interface module and event recorder, which is used to trigger the event, record the data and track event timing, and the other components are event analyst, comparator and the repository, which is used to secure and analyze the data, comparing it against predefined events. So the tasks are recommended to be executed at the process level to simplify the fault isolation and ensure accurate fault localization. Local monitoring systems adjust functions based on the data and securely transmit it to the central system via the standalone network to reduce the traffic. So this architecture demonstrates the adaptive monitoring system. And here uh, we are detailing the methodology we are using in our research. So we have set the objective as to safeguard and to manage the communication between central and targeted distributed monitoring system within adaptive distributed framework. And these two figures, figure 2 and figure 3, demonstrates the distributed monitoring system architecture and the adaptive monitoring model. The monitoring system architecture has been updated to enhance security and efficiency. The DAMS verifies the criticality and security of collected information before it is disseminated. The event analyst is to determine their interest and contrast them with the normal events. It uses repository of healthy events, that is R, for comparisons. It analyzes the changes for size, detail, criticality, and infers the information. It validates the effectiveness of the security mechanism of the target system using proposed metrics. And the components of DAMS, which collects data triggered by the environmental changes from the targeted distributed system and which identifies events on interest apart from the healthy events, analyzes and verifies information, checks for security criticality, sends verified information to the central monitoring system using SSL based on the information criticality. And the security considerations are the risk of intruders hijacking data necessitates careful analysis by the EA. Data is verified against security metrics to quantify the risk. Information is transferred using secure channels or encryptions if deemed insecure or high risk. And this figure 4 and figure 5 demonstrates the use case for the adaptive monitoring system and the activity diagram for the adaptive monitoring system. So here it learns from the environment through the execution and the interaction pattern, adapt to environmental changes based on the learned patterns. It collects data from recognized events and memory addresses where triggered events are stored. And it measures the data complexity using existing security parameters. It also assesses potential risk if unauthorized agents access the information. Adaptive security metrics are used for risk assessment based on the information's criticality. Strategies are devised to safeguard and to communicate data within the central monitoring system. Uh, Parameters such as detail, size, criticality, and support for inference are crucial for implementing the secure mechanism. These parameters help to quantify the information collected for adaptations. It involves assigning numbers or symbols to attributes based on the established rules. It provides insights into the models intended for adaptive monitoring system. And these two figures summarizes the functionality and the activities of our proposed research. And this section details the experimental results. The table 1 demonstrates our proposed model performance in comparison with the traditional models with the given metrics. The metrics are response time, the data processing speed, intrusion detection rate, threat mitigation rate, security criticality, accuracy, service availability, and user satisfaction. This table is evidence that our model, our proposed model is outperforms than the traditional system. This table 2 and table 3 demonstrates the behavior of our proposed system, as well as it compares, it shows the comparative analysis of the proposed system. So our proposed system is performing better than the traditional system in terms of the predefined metrics, as well as at different scenarios like sudden environmental changes and security criticality. And here this table 4 and figure 6 illustrates the impact of QoS of our proposed system. So our proposed system in terms of service availability, so it achieves 99.55 percentage, and in terms of user satisfaction, our proposed model achieves 90 percentage, but in the case of traditional, uh, the measures or the data are not available. And the discussions about our experiment. So our proposed system is responding fast. There is a faster response time, and the processing speed is higher than the other traditional model. The intrusion detection rate is higher than other traditional model, and there is a superior threat mitigation. There is a quick adaptation where it requires only 200 milliseconds, and there is a high security criticality accuracy that maintains 98% accuracy, and there is the enhanced user satisfaction. So our proposed model is considered user satisfaction as a metrics, whereas the traditional model is not focusing on this user satisfaction metrics. And finally, our proposed model improves service availability, user satisfaction, and operational efficiency, making it a strong choice for distributed monitoring system. Finally, I would like to conclude my research. This study addresses security risk in adaptive distributed system and proposes an adaptive tracking component to enhance the security. While the tracking component increases the system flexibility, it also exposes sensitive data to the potential hacker. Hackers can exploit the system by intercepting data and posing as legitimate nodes, accessing private information collected from environmental data. To mitigate these risks, the proposed system transmits crucial data through the encrypted channels, while less critical data is sent via unencrypted channels. The system adapts to its environment to prevent unauthorized access, using security metrics to access data importance and measure the effectiveness of security protocols. The study emphasized the importance of balancing security and quality of service, recognizing that no security system can be 100% effective, but the protection levels are categorized based on the system effectiveness, ranging from excellent to poor. So our proposed methodology in the category of excellent. And the future directions from our proposed work. So testing required in the real world scenarios, and future research will investigate the impact of the overall efficiency and the effectiveness of improving quality, and the monitoring system ability to collect information during malicious events or significant data gathering offers potential preemptively preventing virus and malware attack, which will be further examined. So here I have listed out the articles I have referred, and here I'm detailing the co-author who contributed to these research articles. Dr. P. Sudhakar, Professor, School of Computing Science and Engineering, Galgodia University, Delhi NCR, India, and Ms. A. Abinaya, Assistant Professor, Department of AIML, St. Joseph College of Engineering, Chennai, India, and Dr. E. Thenmozhi, Associate Professor, Department of Information Technology, Panimal Engineering College, Chennai, India, and Dr. K. Tamilarasi, Associate Professor, Department of Information Technology, Panimal Engineering College, Chennai, India. Thank you. I hope this article will help you to have deeper knowledge in the adaptive security system. Thank you.